Heating and cooling problems are based on Newton's law of cooling, which says the rate of change in temperature. Let me point out that capital T is temperature, lowercase t is time. The rate of change of temperature in an object is proportional to the difference in the object's temperature and the temperature of the surroundings, which I'm using M for the medium or surroundings. So this is what we know our differential equation would look like. The constant in this case would of course depend on the sort of object that is heating or cooling. So in this example, we want to determine the initial value problem and find the function. And then finally, we'll use that to determine when will the temperature be a particular amount. So then, starting with Newton's law of cooling and the fact that our medium is at a temperature of 20 degrees, medium meaning the surroundings, we know that in the beginning, 0 for lowercase t, the temperature inside was 70 degrees. Now, we also know that 2 hours later it was 50 degrees. Now, this is called our initial value. Now, from the right-hand side of the differential equation, we know t minus 20 is 0 when t equals 20, so that is our equilibrium solution. We will divide both sides by t minus 20, multiply both sides by dt, and integrate. Separable equation. And then we'll try solving for the temperature, capital T, in terms of time, lowercase t. And we do that by doing the natural exponential of both sides, and then rewriting e to the kt plus c as c times e to the kt. So we'd end up with t equals c e to the kt plus 20. Using our initial condition, lowercase t equals 0, when the temperature is 70, we will solve for our constant of integration. Now, once we get this equation, we are prepared to answer whatever questions befall. And here we're asked for the temperature after 2 hours equals 50. So we'll plug in the 2 for t, 50 for capital T, and solve for the constant k. So there's our equation that we'll use for answering our question. Now, our question that we were trying to answer was, when will the temperature be 40 degrees? So we'll take the equation that we just found, use a 40 in place of capital T, and then solve for the lowercase t. Subtract 20, divide by 50, change to logarithms, and divide by the negative 0.255. That comes out to be 3.6. Now that's 3.6 hours after midnight, which comes out to be 3:36 a.m. in the morning.